Hello everyone, welcome back to the another session in series of learning design and analysis of algorithms, and this concept is about divide and conquer approach or divide and conquer strategy. So what is this approach and what we'll be going to do with this approach? Let's see. So divide and conquer, the name itself it tells that we'll divide and we'll conquer. Okay, now let's understand this. Divide means we'll divide the list into the subparts. So after we divide the whole list into subparts, each subpart or each subproblem will get solved independently. So after we got solution of individual problems, all individual solutions will get combined to get the whole solution or main solution. Now let's look into this. This is what the main problem. So now if I find this problem is not a single one, it's a big one, okay, a very large problem. So that large problem will get divided into smaller pieces or smaller subtasks. Each subtask will get solved independently, something like this. To get the solution of P, we will be dividing the solution P1, will be conquering the solution of P1. Conquer means handle or finding the solution. Okay, now solution P1, solution P2 will be doing it. So once after you find the solution independently or individually, we'll combine it. We'll combine the problem P to get the problem P solution. We'll combine all individual solutions, and this is what exactly divide and conquer approach. Let's see the control abstraction, and this is what the control abstraction of divide and conquer. So algorithm divide and conquer of P. P is what? My main problem. If my main problem is not small, if it is small, that means we'll return that the same. So that means if problem is having only one element, then we need not to divide it. Hence we'll write the solution for the same problem. Okay. If it is not one, that means if it is having greater than of one elements to get solved. So what we'll do is divide P into smaller instances, P1, P2 up to Pk, whereas K is greater than 1. Now apply divide and conquer. What is divide and conquer? We have to divide until our problem will have one single sub problem or piece. So each of this sub problem return combine will combine all individual solutions together. And this is what the control abstraction of divide and conquer. Now let's see the time complexity. The computing time of divide and conquer is described by the recurrence relation. What? G of n. G of n is what? The number of inputs to our subproblem. So just now we were discussed that the problem can have one element, the problem can have greater than one element. If it is having one element, that the growth rate is having only one element. So if it is having one element, let us assume it takes one cycle of time to execute this. So that means n is equal to 1. If it is not having n elements, one element, that means it is having more than one element. Means problem will get divided into pieces or sub-problems, n1, n2, nk. So to divide the time for this subproblem, it will be what? Some n by 2, right? If I have n problem, if I wanted to divide it for 2 halves, then it will be what? N by 2 and n by 2. If I wanted to divide it for 4 problems, then it is what? N by 4, 4 pieces of your n. So now, if I wanted to take the time to execute of this task, what will be the equation? A t of n by b. So t of n is actual problem, a, b are constants. Now the relation of a, b is what? N is equal to b power k. So b is what? B is what? The partitions what you wanted to make. K is what? The constant. So this is what the time which is required to complete each subtask. And this is what the recurrence relation of divide and conquer. This is what the recurrence relation of divide and conquer. Okay. So this is about divide and conquer approach. So let's see the applications of divide and conquer approach in the next video. Thank you all.